Okay, so again, review of the 4 ways that I can ask a mole equation problem. Okay, these are the 4 ways. Try question number 1 for right now. Okay, and then we'll go through that one. All right, so for number 1 here, okay, what we start out with is writing down our givens. We're looking for how many moles, so we're looking for N. Okay, and it tells us it's carbon dioxide, which helps us calculate the molar mass. Carbon dioxide is CO2, so that's going to mean 12.01 plus 16 times 2. So here's the carbon, there's 1 carbon, 12.01, and this is the 2 oxygens, 16 times 2, which is going to give us 44.01 grams per mole for our molar mass. Okay, everybody with me so far there? Okay, so I'm looking for N. The other thing they give me is, they tell me the mass, 150 grams. Okay, the mole equation says that N equals little m, mass, over big M, molar mass. Well, I have those two. I have both M's. So I can just plug them into the formula. It's solving for moles, which is what I'm looking for. So 150 grams divided by 44.01 grams per mole. Okay, and that will give us our number of moles. Okay, so we got 150 divided by 44.01. We're looking at 3.41 moles. Okay. Ringing a bell from yesterday? That's the easiest one. Okay, didn't have to manipulate anything. Okay, just had to plug in numbers. All right. Let's have to try number 2. Okay, we're looking for the mass this time of 26.5 moles of cobalt 2 bromide. Okay, so for number 2, okay, we're looking for the mass, so we're looking for little m, of 26.5 moles, okay, so I know that's little n, okay, of cobalt 2 bromide. So super important that I get the formula right on this. Okay, it's cobalt 2, which means that's the cobalt with the 2+ charge. Bromine is a -1, so we're looking at COBr2. Okay, and so that's going to mean 58.93. Okay, and that's the 1 cobalt plus 79.9 times 2. That's our 2 bromines, and that will give us our molar mass. Okay, so 58.93 plus 79.9 times 2. Okay, 218.73 grams per mole. All right, so now I know the mass of 1 mole, I know the number of moles, and I'm looking for the mass. All right, mole equation says number of moles equals mass divided by molar mass. I want to get mass by itself, so what do I have to do with molar mass? Multiply both sides by it, right? Okay. Okay, so that's going to mean that our mass is going to equal 218.73, the molar mass, times the number of moles, 26.5. So it's going to be a lot. Okay, so 5,796.35 grams. That's not right. 3.5, wasn't it? 3. Okay.
Would you want us to convert that or gas?
No, I want you to leave it in grams, unless it specifically asks for kilograms. Leave it in grams. All right. Any other questions on number 2? Okay. Try number 3. Okay, so number 3, remember you've got an extra step here. We're looking for the number of molecules involved in this one, which means you're going to need Avogadro's number. What does Avogadro's number tell us? The amount of particles in 1 mole. Okay, you're going to need that to get the number of particles, in this case molecules. Okay, so if you can find the number of moles, it can help you get the number of molecules. So in this one, we're looking for the number of molecules. Okay, and we know that this stuff is sodium sulfide, so we can calculate big M. Okay, sodium with sulfide. That's a -2, that's a +1, so we're looking at Na2S for our formula, okay, which is going to be 22.99 times 2 plus 32.07. 06. 7. Okay. All right. So that's our sulfur. Okay. So we have 22.99 times 2 plus 32.07. All right. So we're looking at 78.05 grams per mole for our molar mass. Okay, and the other thing they tell us is that there are 29 grams of sodium sulfide. All right, what can I find with little m and big M right now? The number of moles. So I should do that first. N equals little m over big M, so that'll be 29 grams divided by 78.05. So I have less than a mole here, okay, because 1 mole is 78, and I only have 29 grams, so it's okay to get a decimal here. All right, so 29 divided by my answer. It gives me 0.372. Okay. Again, we want to keep all those decimals for right now. I'm not going to write them all, but we're going to keep them. 0.372 moles. All right. So that's how many moles I have. 0.372. This is how many molecules are in 1 mole. So what do I do with those two numbers to get the number of molecules? Multiply them. Okay. So if I have half a dozen eggs, I go 1/2 times 12 and I get 6. Okay, that's what we're doing here. We're taking 0.372 and we're multiplying by the number in 1 mole, and we're going to get our number of molecules. Okay, so that's going to equal N times 6.02 times 10 to the 23, which will be 0.372, except we'll use all the decimals, times 6.02 times 10 to the 23. Now remember what buttons we have to push in order to enter this. So first I'm just going to say times so that all my decimals come in. Then in brackets, 6.02. Second function, hit the comma, that gives me the E, then I enter in the 23, then I close the brackets, and I am looking at 2.24 times 10 to the 23. Molecules, okay? If there's a unit that people forget, it's that one. Because they have number of molecules, and then they write this number and think that counts for units. Nope. Okay, units come after. Okay, so it's 2.24 times 10 to the 23 molecules of sodium sulfide in 29 grams. Okay. All right, questions on that one? Okay, one last type here. Okay, so we're looking for the mass this time. So they're giving you the number of molecules this time. They're asking you to calculate the mass. It's 7.2 times 10 to the 23 molecules of diphosphorus pentaoxide. Right, so again, you're going to need Avogadro's number, but you're going to use it a little bit differently this time. Okay, you're looking for the mass. So you're going to need to calculate the number of moles before you can get mass. Okay, so on this one, they give us the number of molecules as one of our givens. 7.2 times 10 to the 23. Okay, and then they tell us that it's diphosphorus pentaoxide, which can help me to get the molar mass. So diphosphorus means there's 2 phosphorus, pentaoxide means there's 5 oxygens. So we're going to have 30.97 times 2 plus 16 times 5. Okay, that will give us our molar mass. Okay, so 30.97 times 2, okay, plus our 16 times 5, so our 5 oxygens, 141.94 grams per mole. All right, so now we've got our molar mass and we've got our number of molecules. Okay, we also have Avogadro's number. If I'm going to calculate little m, which is what the question wants me to get, I still need the number of moles. How can I get that with the number of molecules and Avogadro's number?
You take Avogadro's number and divide it by the molecules.
Other way.
Other way, okay.
Right. Number of molecules divided by Avogadro's number will get me the number of moles. Okay? In the same way that if I tell you you have 24 donuts, okay, you go, how many dozen do I have? 24 divided by the number in a dozen, 12. Okay, so in this case we go the number of molecules divided by the number in a mole. It'll get us the number of moles. Everybody follow there? All right. Another way to look at it, mathematically speaking, okay, so if we want to calculate n, it's going to be the number of molecules, okay, divided by Av's number. So if we're looking at it from this perspective, 7.2 times 10 to the 23 molecules, okay, divided by 6.02 times 10 to the 23, and the units for Avogadro's number would effectively be molecules per mole, right? I mean, we're saying Avogadro's number is the number of molecules in 1 mole, therefore its units would be molecules per mole. So if I divide molecules by molecules per mole, what's going to cancel? Molecules. And I'm going to be left with moles. Okay, so if that makes more sense, if you're a mathematical person, that might make more sense to see the units cancel off. Okay, it would be the same as when we said just a second ago, okay, 24 donuts, okay, divided by 12 donuts per dozen, right? Well, the donuts cancel, and we left with 2 dozen, right? So we're doing effectively the same thing here. Okay, everybody all right with that? Okay. So when we do this operation, remember that both of those numbers need to be in brackets in your calculator. Okay, so that'll be 7.2 E23 divided by Avogadro's number. All right, so we have 1.196 moles. Okay. So that's what we have for number of moles. Can I calculate mass now? Yes.
Couldn't you just divide 7.2 by?
Yes, because they have the same exponent, I could just divide the bases, yes. Just as a matter of habit, I don't demonstrate that because it's one more thing I'd be throwing at people on the second day. But yes, math smart, you got it. Okay, all right. So we have now n equals little m over big M. I know little n and I know big M because I calculated it right off the bat. I'm looking for little m, so I would multiply both sides by big M. Okay, that'll let me calculate mass. So mass will equal the 141.94. Okay, times the number of moles, 1.196. Okay, obviously with all the decimals in it when we actually do this. Okay, so we're going to take that and multiply by 141.94. Okay, so we're looking at 169.76 grams. Okay, so that is the one that is most involved. Okay, that fourth type involves having to do the most stuff. You have to calculate the molar mass. You have to calculate the number of moles using Avogadro's number, manipulate the mole equation, and calculate mass. Okay, so you're going to get, that's going to be definitely a 5-mark type of problem on a unit exam or quiz. Okay, incidentally, Thursday's quiz will definitely be on moles. All right, so what I would like you guys to do here now is take a little break first, okay? Give you a couple of minutes here, let's say 2-3 minutes, and then I want you back to work on the mole questions we were working on yesterday. Okay. I I think we were working on number 3, were we not? Something like that. We'll say we're gonna work on numbers 3, 4, and 5, okay? To finish things off. You can take 2 or 3 minutes here, and then we're working on 3, 4, and 5. Okay, remember I did post the key yesterday, and I posted your exam review package as well. Okay, so there's, in that review package is, like the first page is review activities for you to do, and then there's the practice test, and the key is included, okay?